So again, it's very interesting, and it's stone is tactile. We could touch it, except that we don't want to disturb the work.
It's very visual as well.
Yeah. Okay.
And not all the stones are the same.
Yes. Yes, they're not exactly. So if you look at it closely,
it takes a lot of mystery out of it as well.
You trust that the measurement is correct as well, even though they're just placed on the ground.
Yes. Yes.
There's no measurement.
Yes, there's no measurement to tell you. But
and it makes it real.
Okay. And it's amazing that despite all the children coming in and out and running around, that the stones are perfectly placed. So you see, from some of these questions, like it says, take turns describing the lines and shapes. Now, in a way, you answer that for Simon when you came in first. But is there anything else we can get out of that question if we were to take turns describing the lines and shapes of it?
This way, you can see the longest line, and you're looking across at the right angle, where the norm is to kind of see it sitting up.
Yes, exactly. You see it differently. And I like, again, the chalk is another primevalism, or very, you know, if you like, the technology is very much of the past. And mirrors, I think, they're what you're saying, perhaps how the Greeks would have discussed it, maybe with, you know, in thinking of how kind of Pythagoras, when he came upon the theory. And interesting, the maths teacher I told you about, one of the first, he was teaching in Yawn by the sea. One of the first things he did was, when he was trying to use the entry points to bring the theorem to life, he took them down to the beach and got them to draw it in the sand. Now the only thing is that they all went mad going into the water and everything, so it baffled. But it was, at least they began to experience the theorem in some way differently and kind of play around with drawing it. And so it was very experiential then, you see. So one of the reasons we're doing this, of course, is to open up for ourselves ways of developing our own teaching and critiquing it and seeing, are there other ways we might do something? So it's a pity that there isn't someone here from the maths department directly, but perhaps some of you teach maths as part of your courses that you give. But it would be very interesting, like, to look at Pythagoras' theorem if you were to do it this way, and see what you get out of it, the tactile nature of it, but the simple way in which you can see by literally in the squares how the square and the hypotenuse is equal to the sum of the square of the other two sides. You know, and it makes perfect sense. Are there other...
Even Marion, I noticed just from standing here now, because I'm filming, but I always remember in the textbook, you see this Pythagoras' theorem, it looked like it from this side to me here. Yes. But if you move around here, it changes how you see it as you move around. If you went around in a circle there, so...
Move around a little of it and see it different. Yes, because of course you're seeing, now you see, it's not so much the height, I'm seeing the very sharp angle and leading. Yeah, so it's true, so it changes, you're conscious of it much more as a changing force. And I love, as it were, the stone, the simplicity of it, and the simplicity of the wood beneath it. And yet here, I mean, it's fascinating because here is a theorem, as you say, without it, David, no wall, nothing at right angles would be right. This building would collapse without Pythagoras' theorem. We'd have no right angle. So something so simple that just is on the one hand stones on the ground is equally so powerful. You know, as a force literally of literally a very much a global force that really speaks to the very construction of our environment.
In a way, it got me too, when I saw the service, I actually mentally checked what 4 squared was, 16, and I can't see if there was 16 there. You must look for the error.
Yes.
But visually, you can see the pattern is complete, it's not there.
Yes.
It's a triangle there above structure. So where it's kind of where it stays.
Excellent. So literally, I had to spot that. That's wonderful.
That's what I'm trying to get.
Yes, and look at all the angles. It's beautifully placed. Superb. You see, this is the advantage of bringing down.
Gold star.
Look at how literally the whole theorem is replicated in the construction of the walls. Yeah. So when you take time to look at something, and Keith's bicycle is always
many angles.
Well, I've never understood this theory. This is the first time I have understood it.
Listen,
I have to be honest.
but isn't that, it was the same with me. I was exactly the same in water. I feel that it's a revelation, something so simple.
Yeah.
And so beautifully done. So we must see if there is only just as well in terms of trying to look at questions to help us. We'll skip the one saying sing along, sing a song and then express it. Like, the other works around. Yes, I think you're really answering the question. Take a look at this is on the second page of the aesthetic for those later if we have it up, we're trying to look at it. Take a look at the other works of art displayed around it. Now you might say the building itself is a work of art, and there's nothing else in this corner but the George Boole 2000 celebration and the explanation of his life. But if you look at the building itself, that so therefore, there in that sense there is a work of art around it. And finally, sorry, we're having difficulties thinking. Are there other questions in particular that you think would speak to it? Do you see when you asked there, do you see movement? The second last question. Do you see movement in this work of art under aesthetic again? Do the colours, lines and shapes make it seem that way? So is there movement in it? Like in what way?
You've got white stones and kind of different colours, and they're kind of drawing your eye into different angles.
And the shadows.
Yes. Good. Eileen,
The lines draw you in and out, when you're actually following it, so the art of the connection.
yes. And as you say about the shadows, and when you walk, the light from the shadow, like when I walk into it now, I kind of cast a big shadow across it, so therefore it's not static in that sense, it's moving. So the angles, you can move around it and negotiate it, so it's moving and you're moving, so there's much that you can do with it. Yes, now I like, of course, it's just as a matter of interest to read another aesthetic one and then the experiential. Describe the space that you see created by this work of art. Does it remind you of a place in your own life? Now, you see, they're thinking of a more classical painting maybe, but when you're thinking of the space created, your story, Dave, of what you said, about the fact that the carpenter who used it, so that he saw it in that way, described the space you see. So there's many spaces created by it, but literally the head space, I think, more for yourself and myself to get our heads around the theorem. So we could say that's a place that reminds us of in our own lives, but literally a place. Is there anything else to be said there?
Of teamwork.
Sorry?
Reminds me of teamwork.
Teamwork?
Two sides adding to make a bigger whole.
Good. Excellent. That's brilliant. A good metaphor of teamwork, Flores says, because it's as if, when you add that two sides, you get a third one. Something that's bigger, the part is, the whole is greater than the sum of its parts. And the experiential one, I love this last question on the experiential page. It says, is there something that has happened in your own life that this work of art makes you think of? Now, and I recounted that earlier, my own fear, like of Pythagoras' theorem and what I do with it, and would I recognise the chance to use it in the exam, always the exam note. So I'll draw a picture of the experience. I'd have to draw something like Edward Munch's The Scream, where I was terrified. Like, I'd be like this, kind of trying to think, how would I knowing the theorem by heart, with no concept of how I was actually going to use it. So there are other stories like that, perhaps not quite so dramatic. Something happens that reminds us, and I suppose the story I told you of that maths teacher in New York. That's something, he's using it because he was getting so frustrated that the class had no clue about it, and so he took them to the beach. But then what was successful for him was telling the story of Pythagoras to the class, and they're realizing that this kind of was a family man, that he had a life, and why did he need this theorem? So he hooked them into it then, and that was also an relational entry point, and it was equally an experiential one, and aesthetic in the sense that he took them to the beach. So I suppose one of the fascinating things is that there's a dynamic relationship in the entry points. You might use, several of them will collide at once. Great. So is there anything else you'd like to say about it before?
I remember Marion, I went on a sailing boat with somebody, and they were showing me how they navigate, and they were saying how they could only figure out where they were, hundreds of years ago, after they published the longitude and the latitude tables. And one of the big things was trying to figure out was getting a watch that was accurate, so they could time how far they were from certain places, so they could see the angle of the sun, and then they could get an idea how far they are from England, from Greenwich, and then they could navigate where they were in the world. Because otherwise, if they couldn't tell the distance, they couldn't tell their height and their angle. So it was, you know, they were using sextants, but it all goes back to Pythagoras' theorem.
Exactly. And then equally though, in the light of what you're saying, that next piece of art here literally taps into that, because that game is controlled, if you like, by the avatars and figuring out the angles as much as they would have done say old sailors, like trying to figure out the angle and in the light of how far they were from A to B, so to say. So the idea anyway of celebrating Boole and White as a professor of mathematics was to take Boswell's work and look at it and see how in that sense it celebrates the notion of mathematical formula, making it very real, very tactile, and you know, very clear really as to the, I mean, as you would have thought, I thought Vera's point was going to take you on that in the Greeks, that this would have been the way perhaps literally on the sand and stone that would have looked. Great, so we're going to go on now, John.